first time you read through it. Read through it once, process as much as you can, and then read through it again. So it says a surveyor is 100 meters from a monument. Do not draw this, but I will show you that generally speaking, here's my ground. When they're talking about somebody or something or like a dog or a cat or a person, I always just make them a dot on the ground. So there's my surveyor dot on the ground, unless the word problem gives them height. So if the word problem does not give them height, then they're going to be a dot on the ground, whether it's an animal or a person or whatever it is, or a boat or whatever it is, you're a dot on the ground. So initially, this is how I would do this. Don't draw it because it's wrong. So initially, if I'm reading through this step by step, a surveyor is 100 meters from a monument. So I draw the surveyor as a dot on the ground, and I would draw the monument with some height. The reason I would draw the monument with some height is because it says the angle of elevation to the top of the monument. So because it didn't really say the monument was higher, but they're saying there's an angle of elevation, meaning from the person has to look up to the monument. So can I look up to a monument if it's not taller than me? No, it has to be taller than me for me to look up to the monument. So I had to give the monument height, even though it didn't specifically say that the monument was so tall or anything. So far, if I were reading this, this is what I would do. It'd say a surveyor is 100 meters from a monument. The angle of elevation to the top of the monument is 41 degrees. Still don't write this because this is wrong. So I would say, okay, from the surveyor to the monument is 100. So I'd label that with 100. Then I would say the angle of elevation to the top of the monument is 41 degrees. So it's going to the top of the monument. Who would you suspect this angle of elevation is coming from? Who's looking at the monument? The surveyor. So now I have to make an angle of elevation from my dot person surveyor to the top of a monument. Now I have to remember an angle of elevation comes from a single point, that person, and part of the angle is looking up and the other part has to be horizontal. And they're saying this angle is 41 degrees. And based on everything I've read so far, this diagram is corresponding beautifully. But here's where it throws us for a loop. Now it says the surveyor's instrument is 1.5 meters above the ground. Up until this point, I was able to make that surveyor a dot on the ground. But now in this one sentence, the surveyor's instrument is 1.5 feet above the ground. I have now given the surveyor what? Height. And once they give the surveyor height, we can't disregard that. He can no longer be a dot on the ground if they're now incorporating the height into this problem. So now I realize that my drawing is not good and I have to erase. And that's okay. We start over. So now I'm going to take into account that the surveyor has to have height. So now I'm going to give the surveyor height. I'll make him one big blue eye. There's my surveyor. He's looking at a very tall monument. So the surveyor is still 100 feet from the, or 100 meters from the monument. So that's still 100. Right here, that's still 100. Okay. The angle of elevation to the top of the monument. Again, we have to remember that angle of elevation is coming from the surveyor, but now the surveyor is not on the ground. Isn't this the surveyor's eye right here, this blue one? So now we're going to make an angle of elevation from the surveyor's eye. So one line of the angle going up, one ray of the angle going horizontal. And this is 41 degrees. Okay, let's keep going. So now we read the surveyor is 100 meters from the monument, got that, marked it, check. The angle of elevation to the top of the monument is 41 degrees, got that, marked it, check. The surveyor's instrument is 1.5 meters above the ground. Where do you think I'm going to label that 1.5 meters? Isn't that good? Because that was where we gave the surveyor height. Find the height of the monument to the nearest tenth. Okay, so ultimately, do we all agree I need to find this total height? But now we have the right triangle right here. So I have the right triangle up here, but that's not the whole diagram. What shape is below? If you had to take a guess, what shape do you think is below this right triangle? A rectangle. And recognizing that as a rectangle is super important. Why is that super important? In a rectangle, opposite sides are congruent. So if the bottom is 100, the top is also 100. And if the left side is 1.5, the right side is 1.5. So now what I'm going to do is I'm going to use this right triangle and I'm going to find x. But when I find x, is that good enough to say that's my total height of the monument? No, x is just this, right? To get to the ground, I'm going to need to find x and then add what to it? 1.5. So now we have our plan. I'm going to first find x, and then once I find x, I can add 1.5 to it. Is anybody confused with my process here or how our thought process of going about this? Okay, so I'm going to use the pink triangle. And I'm going to do everything in reference to the 41. And x is opposite 41, and 100 is adjacent to 41. So if I'm going back to SOHCAHTOA, which one should I use for opposite and adjacent? TOA. Then I have to ask myself, what is the T in TOA? Tangent. So we're going to say the tangent of 41 is equal to the opposite side, which is x, over 100. And now we have to remember our algebra skills. I'm going to solve for x. If I'm going to solve for x, I'm going to multiply by 100 on both sides. So these 100s cancel. So I'm going to have x is equal to 100 times the tangent of 41. Yes?
You always multiply by
Yeah, so for that problem, we had to multiply by x to get x out of the denominator, but then that wasn't enough. After we multiplied by x, then we still had to solve for x by dividing. So let's go into Desmos now. Here's my Desmos. So remember, go to scientific. And I'm going to do, what was the problem? 100 times the tangent of 41. Guys, also, I don't know if I ever pointed this out to you, but do you guys see how it says RAD and DEG? It should always be on DEG. That's degrees. The other one is radians, and you won't use radians probably till calculus. So we're going to do DEG, degrees. So we're going to do 100 times the tangent of 41. Is this my answer? No, this is not my answer. Why is this not my answer? Go back to the problem. X wasn't good enough. We needed to find X and then do what with it? Add what? 1.5. So in your Desmos, just as it is, you're going to now write plus, or close those parentheses, and then you're going to write plus 1.5. And now, is this your answer? Yes. And so your answer is 88.42. If we're rounding to the nearest tenth, it's 88.4. So we're going to say the height is 88.4 meters. And that's our answer. Yeah.
Like main problems like these, like it's the little order, but like we went in order, but then when we actually got to the 1.5 meters per then probably.
So exactly what we did. So we went in order. We started creating our diagram, which was perfect. And then when we got to the 1.5, we realized, let me erase and do this all over. All right, number 5. April is in a plane that is at an elevation of 500 feet. She spots a person sunbathing on the roof of a 225-foot building. The distance from the plane to the person is 360 feet. Find the angle of depression to the sunbather. We're not rounding to the nearest degree. Let's change this, round to the nearest tenth. So I read through it once, reading through it again. April is in a plane at an elevation of 500 feet. Can I make April a dot on the ground? No. What specifically tells me that I cannot make April and this plane a dot on the ground? Jack. Good. It's saying April is in a plane that's at an elevation of 500 feet. What does that mean, at an elevation of 500 feet? It means she is 500 feet from where? The ground, exactly. So because we gave her height, because we gave that plane height, we have to consider it. So here's my ground. April is in our plane. Here's a plane, and she is at an elevation of 500 feet. So from April to the ground is 500. Here's April's eye. All right, April's in a plane at an elevation of 500 feet. Check, we got it. She spots a person sunbathing on the roof of a 225-foot building. Can I make the person sunbathing a dot on the ground? No, good. Kate, why no? Because she's on the building, but more than just being on the building, what did they say about the building? Exactly. So they're saying April is on a building and that building is 225 feet. So because they're giving the building height and April, not April, the sunbather is on the building, don't I now have to draw that building with some height? If they didn't give the building height, could I just draw it as a dot on the ground? Absolutely. So now we're giving that building some height, 225. And we will make the sunbather a dot on the building. So now I'm reading over again. April's in a plane at an elevation of 500 feet. Check, we got that. She spots a person sunbathing on the roof of a 225-foot building. Check, we got that. The distance from the plane to the person is 364 feet. Whenever they're talking about the distance, they're talking about the most direct distance. And what is the most direct distance between any 2 points? Isn't it a straight segment? So when they're saying the distance from the plane to the person, they're talking about that straight segment from the plane to the person is 360. Find the angle of depression to the sunbather. If the angle of depression is looking at the sunbather, and you had to take a guess right now, where would you guess the angle of depression is coming from if they're looking at the sunbather? What's the only other part of this? That's the only other thing being talked about. Only other person being talked about. April, right? Because what does it say? April spots a person sunbathing. So wouldn't it be April's angle of depression to the sunbather? So if the angle of depression is coming from April to the sunbather, April, this blue point, is our starting point for the angle of depression. And now remember, an angle of depression is always one segment looking down or one ray of it looking down. But what does the other side of the angle have to be for angle of depression and angle of elevation? Anybody remember? It would have to be horizontal. So many people want to call this theta. That's not theta because that would be an angle, one side looking down and one side up and down. We don't want up and down. We want left and right. So guess what I have to draw? Another segment right here. And this is the angle I'm trying to find. Are we okay so far? Okay, now, do you guys see how I have this sort of gap here? It's open space. I'm going to close that up. Does anybody know why I'm going to choose to close this up? Exactly. Because when I close that up, I end up making a right triangle. And not only am I making a right triangle, which is perfect, which is exactly what I want. What is this bigger shape here, if you had to take a guess? Bigger one. A rectangle, yay. It is a rectangle. And in a rectangle, aren't opposite sides congruent? So if the left side is 500, then the right side is also 500. Why does this matter? Anybody know why this matters? We obviously want to use this right triangle, right? And I have the 360, which is one side. But can I use trigonometry with just one side and no angle? So no angle and just one side. Can I do that? No, I need another side. So I have to find this side right here. Any guesses on how I can find that side? Stella? You got it. 500 minus 225 is 275. So now we want to find the angle. I'm going to go label the two sides that I have. What is 360? Opposite, adjacent, or hypotenuse, Jay? What is 360? Is it opposite, adjacent, or hypotenuse? It is the hypotenuse. How do you know, Jason? How do you identify the hypotenuse? Good, because it's across from the right angle. And then the 275 is opposite because it's far away from the theta. So if I'm going back to SOHCAHTOA, which one am I using? SOHCA or TOA? So then I have to ask myself, what is the S in SO? Yeah. And you can never write sine alone. What is it going to be? Sine theta equals 275 over 360. Who remembers when we're solving for an angle, what do I have to do? When we solve for an angle, what do we have to do? The inverse, excellent. So in order to solve for an angle, that's when we do the -1. So it's going to be theta equals the inverse of sine of 275 over 360. Let's go to Desmos. Who remembers how to get the inverse on Desmos? What do I have to press? Function, perfect. So we're going to say, oops, let's clear all. We're going to say inverse of sine. And that was, what was my numbers? 275 over 360. Oops, what happened here? There we go. And that's going to be 49.80, which is 49.8 degrees.
When, like, whatever, like, take on this, if we forget to put degrees, would that count as wrong?
No. So if you forget to put degrees, it won't count as wrong. But if you put degrees when it's not supposed to be degrees, then that will count as wrong. Yes. All right, last problem, guys, together. Jay, was your hand up or are you just stretching? Okay. Greg is standing on a dock looking at a ship 50 feet away. The angle of elevation to the top of the sailor's head on the ship is 24 degrees. The angle of depression to a point where the water comes up on the ship is 32 degrees. How far is the top of the sailor's head from the water round to the nearest tenth? I read through it once. And it's saying Greg is standing on a dock looking at a ship 50 feet away. The angle of elevation to the top of the sailor's head on the ship is 24 degrees. The angle of depression to a point where the water comes up on the ship is 32 degrees. Technically, right now, as I'm reading through this, it doesn't seem like they're giving height to anything. They never said the dock is 100 feet from the ground. They never said, the sailor is 6 feet tall. They never said anything. They're not giving it height, but at the same time, I can't make it all dots. Why am I not able to make this all dots? Let's talk about, don't draw this because I don't want it to be wrong. So let's say we're making Greg a dot on the ground, okay? So here's Greg, and then he's looking at a ship 50 feet away. Here's the ship. And here's the 50 feet. But then it's saying the angle of elevation to the top of the sailor's head, which means the angle of elevation is coming from who? From who? Who's looking at the sailor? Greg. So it says the angle of elevation to the top of the sailor's head. That means it's going to the sailor, so it must be coming from Greg. Now, if Greg and the ship and the sailor are both dots on the ground, am I able to make an angle looking up? I can't. So what does that tell me? I have to give whose height? I have to give the sailor some height. So now here's my sailor. Let's keep going here. The angle of elevation to the top of the sailor's head on the ship is 24 degrees. So we just talked about this. Don't draw this because it's still not right. So now the angle of elevation is coming to Greg and looking at the sailor. So would I accurately be able to make an angle of elevation here the way this is drawn? One line looking up, one horizontal, we would be good, right? But then there's more here. There's not just an angle of elevation. They're saying the angle of depression to where the point, to a point where the water comes up on the ship is 32 degrees. So what's happening here, Greg is here, he's looking up at the sailor, but then he's also looking down at the water. So now coming from Greg, I can make an angle of elevation looking up. But if he's just a dot on the water, can I make an angle of elevation looking down, a depression looking down? No. So what does this mean? I also have to give Greg some height. So now I'm going to erase this dot. And I'm going to give Greg some height. So he's on a dock. So there's my dock with some height. Now you can draw this. And we're gonna add a little bit more to it, but we'll talk about that in a minute. Okay. So now let's go back, read it again. Do you notice that we read the problem so much and it's necessary to get every little part of it to go back and keep reading? I'll never expect you to get a problem of like, this complicated and read it once and know what to do. You got to keep piecing it together. So it says Greg is standing on a dock looking at a ship 50 feet away. We've marked that. The angle of elevation to the top of the sailor's head is 24 degrees. Have we marked that yet? No. So now we ask ourselves again, the angle of elevation is looking at the sailor, Jay. Bathroom? Yes. The angle of elevation is looking at the top of the sailor, but where is it coming from? Who is it coming from? Greg. So remember, Greg was our blue dot. So here's Greg looking up to the top of the sailor's head. And now remember, an angle of elevation is one part of the angle, one side of the angle looking up, and the other side has to be horizontal right here. And this is 24 degrees. All right, so the angle of elevation to the top of the sailor's head is 24 degrees. We got that. The angle of depression to the point where the water comes up on the ship is 32 degrees. Okay, now a lot of people think that how is it possible that the angle of elevation is coming from Greg, but now the angle of depression is also coming from Greg? That's perfectly fine. Can I be one person here and can I look up at the ceiling but then look down at the ground? It's okay. The angle of elevation and angle of depression can absolutely come from the same person. First he's looking up, then he's looking down. So now we have to create that angle of depression. So that angle of depression is coming from Greg once again, but this time instead of looking up, he's looking down. And one line of that angle, Bella, is looking down and the other one is horizontal, right? And this is 32 degrees. Is it okay that I have the same horizontal line for both the angle of elevation and the angle of depression? Yes, it's absolutely okay. So the bulk of this problem, the drawing of this problem is finished. We got the hard part done. So now, how far is the top of the sailor's head from the water? Do we agree that ultimately I need to find this total height? Where do you think my right angles are? So basically, if I were to close this up right here like that, these are my right angles. So how many right triangles do I have here? How many right triangles do we have there? Isn't it two, right? I'm going to highlight one of the right triangles in yellow. And I'll have another right triangle in blue. And so I have the yellow right triangle and I have the blue right triangle. You guys see the rectangle underneath on the bottom here? Why is this rectangle going to be helpful to us? Anybody know? Because it's always about the right triangles in trigonometry. But this rectangle is going to help us with something. Does anybody know what the rectangle will help us with?
Because opposite side of the rectangle are here.
Perfect. It's going to give us a side length of the triangle. If the bottom is 50, isn't the top 50? So that gives us this horizontal segment is 50. Now, do you think we'll be able to use just one of these triangles to solve the problem? No, I need the total height. And so neither triangle talks about or will get us the total height. But if I call this X and I call this Y, if I solve the yellow triangle for X and then I solve the blue triangle for Y, can I add X and Y together to get the total height? So that's what I want to do. So let's look at this yellow triangle. So we have x is opposite. Fifty is adjacent. So if we're going back to SOHCAHTOA, we're going to use tangent. So the first problem is going to be the tangent of 24 equals x over 50. To solve this, I'm going to multiply by 50 on both sides. So the 50s cancel. So now I'm going to have x is equal to 50 times the tangent of 24. I'm not done yet. Now I want to use the blue triangle. So I don't have to keep going back and forth. I'm going to now find the blue triangle. So in the blue triangle, y is opposite and 50 is adjacent. So once again, I'm going to use tangent. So this is going to be the tangent of 32 is equal to opposite y over adjacent, which is 50. We're going to multiply by 50 on both sides. The 50s cancel. So we're going to say y is equal to 50 times the tangent of 32. Everybody good with how I solved the two triangles? And now, what should I do with x and y once I get them to find my total answer? Put them in decimals and then do what with x and y? Add them, exactly. We can actually add them right away in decimals. I'll show you how. So let's go to decimals. I'm going back to my main. I'm going to clear all. And so the first one was 50 times the tangent of 24. So we're going to type that in, 50 times tan 24. Close that parenthesis. The parenthesis closes under cosine. Then you're going to write plus, because we're adding these two together, right? Plus, and then we're going to do 50 times the tangent of 32. And this is my final answer, 53.50, which is 53.5. So we're going to have how far is the top of the sailor's head from the water? We're going to have 53.5 feet is our answer. Alrighty, guys, we are done. You do have homework. I will show it to you now.